Okay, let's get started today. Welcome to the North Central Climate and Drought Outlook for March. My name is Doug Cluck. I work for the National, who do I work for? I work for NOAA, National Oceanic and Atmospheric Administration, and more specifically, the National Centers for Environmental Information. I'm based out of Kansas City, and we're going to be joined today. Our presenter today is Trent Ford, who is, as it says right there, the Illinois state climatologist, and by Dennis Toddy, who is the director of the Midwest USDA Climate Hub out of Ames, Iowa. Trent's going to give the talk, and we have a lot to talk about. I guess I'm sorry to say that, but there's going to be a lot of information, like usual, presented here, and so we may run a bit long. And if we do, we hope not to go too much past 2 o'clock. We'll still have our Q&A session at the end, question and answers. So Dennis and I and Trent can try to answer whatever questions that pop up. So use the question. If you have any questions or comments, please use the question interface on the webinar thing to get going. So without any further ado, let's get going here. Trent, take it away, and thank you.
Yeah, thanks, Doug. And thank you all for taking some time out of your basketball watching today to listen in here. So just some general information real quick. You know, the webinar, for those of you who may not have been to one of these before, the idea is providing climate services for the entire central region as a collaboration between USDA Climate Hubs, the State Climatologists Association, Midwest, and the High Plains Regional Climate Centers, and a bunch of other groups of folks. Past webinars, this webinar in a little bit, and future webinars will be posted on the Midwest Regional Climate Center and High Plains Regional Climate Center websites. As Doug mentioned, we'll have open questions at the end. And just a heads up, our next one of these is Thursday, April 21st. It'll be hosted by the man, the myth, the legend, Dennis Toddy, the USDA Midwest Climate Hub Director. For now, you're stuck with me. Here's the outline for today. We're going to do past, present, future, or some recent climate conditions. February, wrap up the winter review, climatological winter. Look at some current conditions, including hydrology, drought, which of course will be a big theme here, some things in the Great Lakes, impacts, and then we'll look to the recently released outlooks, both near term, longer term, and then looking at ENSO. All right, so let's start with some recent climate conditions, a bit of a wrap up. Starting with February, these maps are showing on the left temperature rankings for the month of February for each state, and on the right precipitation rankings. So for temperature, the lower the number, the colder the month of February was. So you can see here kind of these whitish colors for most of the region, where February was pretty close to normal as far as temperatures were concerned for most of the region. A little bit colder in Minnesota, as I'll show here in a few subsequent maps, and as well as Colorado's top 30 coldest February, Minnesota. Like I mentioned, closer to normal elsewhere. For precipitation, February really reinforced the sort of longer term patterns that we've seen, at least going back to last fall, which is wetter to the east. That's the larger numbers, the green colors on the map on the right hand side, and drier out west. So last month was a top 5 driest February on record, and these records go back to 1895. Top 5 driest February in Wyoming, Nebraska, and Iowa statewide. But it was also a top 10 wettest February for Ohio and Indiana. And in Ohio specifically, it was the wettest February on record for 6 Ohio counties. So again, this pattern that we've seen for a while now, where it's dry farther west, wet east, especially in the Ohio Valley, was really reinforced in February. For the overall climatological winter, which as a reminder runs from December 1st through the end of February, this is looking at temperature summaries for this last winter. Again, these are rankings on the left by county, and then on the right of the state rankings. So anywhere you see red, either the lighter or darker red colors, that's where we had either above average or much above average temperatures in winter. And we can see here that, you know, this last winter was warmer than average for really the southern 2/3 of the region. But it was really a tale of 2 winters. So if you remember back to December, it was very warm across much of the region. You know, top 5 warmest December on record for several states. And then January and February were actually either near normal or actually on the cool side. But December was such an anomaly that it outweighed everything. So the very warm December really outweighed the cooler January and February, and ended up being a warmer than normal winter season for most of the states, at least in the southern 2/3 of the region. And this last winter, again, looking at just the average may not tell the entire picture, but it is a sort of another point in a long-term increasing trend in winter temperatures for the region, from the Rockies through the Great Lakes. And that's what this plot shows here, is the winter average temperature, again, December through February, going back to 1895 for the whole north central region here. And we can see that winter temperatures have been increasing by about 0.3 of a degree per decade. So again, a point in this longer term trend that we're seeing warmer winters in the area. On the precipitation side, again, this was, I mentioned this when talking about February, the overall climatological winter season was very similar, with this wet to dry pattern, very wet in the Ohio Valley, as well as in northern Minnesota and the northeast corner of North Dakota, but again, dry, especially in the central and southern plains. It just reinforced this wet east, dry west pattern. Some specific statistics here: 11th wettest winter on record in Minnesota statewide. It was the 4th driest on record in Nebraska and the 5th driest in Kansas. And it was the driest on winter on record. And again, these records go back to 1895. The driest winter on record in 6 Nebraska counties. You can see those in this map here in the dark brown colors, and the driest on record in 1 Kansas county as well. To give it just a little bit of a local statistic here, is the 2nd driest winter on record in Lincoln, whose record goes back to the 1800s with 0.56 inches of total precipitation. That's liquid and solid precipitation put together there for Lincoln. So very, very dry winter, especially for the Central Plains there. A little bit more recently, these maps are showing precipitation summaries for the last 60 days. And what we see here, the total amount of precipitation over the last 60 days on the map on the left, and then the percent of the 30-year normal that total represents on the right. So really the western Midwest and the plains have been, really between 1 and 2 inches drier than normal. Depending on where you're at, if you're further east, that could represent maybe 40 to 50% of your normal. In parts of Nebraska, northern Kansas, South Dakota, that's closer to 10 to 5% of your normal precipitation. So it is pretty, you can see especially the map on the right-hand side, this is pretty large area of eastern Nebraska that's seen, less than 25% of its normal precipitation over the last 60 days. One thing I should mention here is that, and this will be apparent in the snowfall maps here, is that in the last 60 and 90 days, the green areas that we see, those in the Ohio Valley, and then again in northern Minnesota, parts of the Upper Peninsula, Michigan, and northern Wisconsin, those are 2 very different types of precipitation. In the Ohio Valley, it's been 1 to 5 inches wetter than normal, but that's been almost entirely rain over that time period, which has led to some flooding in those areas that I'll talk about in a little bit. Whereas the majority of the precipitation that's fallen in northern Minnesota has really been snow. It's been quite a snowy February, especially in the start to the year there. So that's an important distinction made there. Also, just kind of to call out this box here, the period really the beginning of this year, January 1st through March 16th, was the driest on record in Norfolk, Nebraska. Again, record that goes back to the late 1800s, and the 3rd driest on record in both Grand Island and Valentine, Nebraska. So again, this is very, very dry winter overall. That's also remarked here in the last 60 days. When we look at the last 90 days, it's again very similar pattern. Again, total precipitation over the last 90 days on the left, the percent of normal that represents on the right. Again, most of the whole region's been 1 to 6 inches drier than normal the last 3 months. Eastern Nebraska, again, less than 25% of normal precipitation since that mid-December period. On the flip side, again, that east to west gradient, parts of southern Illinois, southeast Missouri, Kentucky, Ohio are 6 to 8 inches wetter than normal over that time period. Similarly, in northern Minnesota. And again, it bears out repeating here that much of the Ohio Valley has experienced the wetness in the form of rain, whereas snow has really been the predominant driver of those numbers in northern Minnesota. I'll also mention here that coming from Illinois, you can see this gradient between the wet and dry really clear across central Illinois. I mean, we only have maybe 2 or 3 counties between areas that are at 150% of normal for the last 90 days and areas that are closer, less than 50% of normal in parts of Illinois, Wisconsin, and Missouri. So again, this is really, you know, the dry west, wet east has been something we've seen for a while, but even within the central Midwest, there's quite a tight gradient between the haves and have-nots. That's really remarkable. Temperature-wise, over the last 60 days, I kind of mentioned this when we were talking about winter temperatures overall and February temperatures. It's been colder outside of eastern Montana and a few places in South Dakota. It's been below average as far as temperatures over the last 60 days. And this big blue purplish area in the upper Midwest has been anywhere between 4 and 10 degrees below normal. So again, you know, quite a contrast to the very, very warm December that we saw to start the winter. February was pretty cold for this part of the region. And that was definitely reinforced by persistent snowpack in that region that definitely can have its effect on temperatures. Of course, our air temperatures definitely translate to soil temperatures this time of the year. What this map is showing are 4-inch soil temperatures under sod. And this is the Midwest Regional Climate Center's a network of networks here trying to stitch together measurements from multiple different networks. That's where we have the points there. You know, in general, 4-inch soils remain frozen really in the northern half of the region or around that 32-degree mark, especially central Iowa north. That's where we're still seeing, you know, some sort of frozen soils or soil frost in the profile. South of there, once we get into parts of Kansas, central southern Illinois, Missouri, that's where we're starting to see soil temperatures, you know, in the high 30s, even up into the 40s. We actually have a 4-inch bare soil temperature in Champaign this morning that hit 45 degrees in central Illinois. So, you know, we're definitely, even in the places where there's still soil frost, you know, the lack of snow that I'll talk about here in a little bit, and this recent mild weather and the outlook's sort of looking that way as well, we'll definitely see the soil frost depths decrease pretty quickly here. And that's, I mean, I imagine if I were to show this map next week, it would probably show quite a bit of difference, especially in this transition area in parts of Iowa and Wisconsin. Specifically for soil frost depths, you can see the numbers there, and they have the legend down the bottom left-hand corner of the map. We're seeing soil frost depths that are still, you know, 30+ inches. I mean, we have central southern North Dakota, it's 46 inches still of soil frost. You know, it's been cold in that part of the pretty cold in that part of the region over the last 60 days, as I mentioned before, and it's had enough snow to really keep those soils insulated from the warming temperatures. But again, I would expect that as we begin to see the snow melt, that those soil frost depths will start decreasing pretty quickly here. Further south, we're, you know, 12 to 15 inches in parts of southern Minnesota, Wisconsin, central Iowa, and then once you get farther south, all the way throughout Illinois, Missouri, Kansas, Nebraska, we're seeing pretty much the entire soil profile is entirely or mostly thawed. So we're definitely getting into that point where soils are getting to the point where they're workable, at least from a temperature standpoint. Snowfall, I sort of mentioned this before. So these maps are showing snowfall as a departure from normal on the left and as a percent of the normal on the right. And this is since August 1st of last year. So if you take this whole region, that's sort of our, you know, snow season here, starting in August 1st. You know, in general, we see that the majority of the region, at least by landmass, is close, but a little bit behind on their snow so far. And that's really bears itself out in the percent of normal. You know, we talked about how dry the winter has been in eastern Nebraska. That really bears itself out here, where this large area between Sioux Falls and Lincoln is, you know, anywhere between 10 and 25% of normal snowfall for the whole season. And that also makes its way up into most of South Dakota as well. And you know, when you look at these two maps, there's really only 2 areas outside of the mountains that have picked up, you know, above normal snowfall. And that is the northern half of Minnesota, northern Wisconsin, the UP, and northeast North Dakota, as I talked about before, that had a pretty hefty snow total for February. February. And then this interesting corridor from Kansas City through Chicago. And that was really this area, if you live in that area, where we saw several winter storms make its way through. And here in central Illinois, we'd have this area, this I-55 corridor between St. Louis and Chicago, where it would drop 14, 15 inches of snow in a 3-day period. But you could drive 50 miles out of the way and you'd still you get to trace amounts of snow. And so that's really the only areas where we've seen above normal snowfall for the season. Just want to shout out here a pretty good snowfall event here in late February across the upper Midwest, where you see, everywhere in orange here picked up at least 8 to 12 inches of snowfall. And a Cocoa Ross observer in the beautiful town of Bayfield, Wisconsin, measured 25 inches of snow in 72 hours. That's certainly not unheard of in this part of the country, but impressive nonetheless. So, when we think about winter overall, we can characterize winter in so many different ways, but one metric that I really like is called the accumulated winter season severity index, or Aussie. And what it does is it represents kind of an accumulation of winter season severity day by day that you can look at any point in the winter season and compare the current season with historical seasons to say, is it near average? Is it severe as far as winter severity? Is it moderate, mild? So on and so forth. And so you can see the points here. The red dots on this map are showing areas where the winter so far has been pretty mild, well below normal severity, and it's obvious where that's at. In those areas of basically the snow holes of eastern Nebraska, a lot of South Dakota, even into eastern Colorado and Wyoming. We got the kind of severe to, in some cases, extreme winters of northern Minnesota and North Dakota, where again they picked up a good amount of snow and been cold for a while. And then the eastern Corn Belt, it's been really a mix, near average to maybe slightly above average, where we did pick up some snow in parts of Illinois and Missouri, but especially most of Indiana and Ohio have seen a pretty mild winter thus far. All right, so moving to kind of our current conditions, especially focused on hydrology here. Sticking with the snow theme, what these maps are showing, you see the snow water equivalent map on the left-hand side, and then the right-hand side is showing our current snow depth departure from normal. So really, again, outside of the mountains, really the only place where we still see snow water equivalent or snowpack on the ground is that northern part of the upper Midwest, where we're seeing anywhere between 1 and 4 or 5 inches of snow water equivalent on the ground still. And when you compare that as far as snow depth to normal, that's what the right hand, the map on the right hand side is showing. Anywhere you see yellows and oranges, that's where we're below average or below normal as far as the snowpack for this time of the year. And so, when you look at the yellows and oranges in most of South Dakota, southern Minnesota, northern all of Iowa, and most of Wisconsin, those are areas that are below normal snow depth. But importantly, as the map on the left-hand side showed, there is no snow, or very, very little snow on the ground there. When normally, for example, for northeast South Dakota, you'd expect this time of the year to have snow depth between 2 and 5 inches, maybe a good inch or so of snow water equivalent. That's just not there. As we get into talking about drought here for this presentation, I'll make mention a lot of the drought maps do take into account the precipitation deficits, which do include, snow deficits. But a lot of times if we're entering, this time of the year in a bit of precipitation deficit, a lot of times we can depend on a little bit of snow melt to help boost some stream flow. And, for a lot of places outside of the upper Midwest, that's just not the case this year. Focusing on the mountains here, I have a lot of the basins that make up the upper Missouri here circled in red. This is showing snow water equivalent as a percent of normal from today. The northern basins, parts of Wyoming, Montana are closer to 75 to 95% of normal snow water equivalent. A bit closer to normal in Colorado. We have some 99%, 103%. So down there, so we're seeing closer to normal snowpack for this time of the year there. Specifically for Missouri, the Missouri headwaters are at 80% of normal right now, and then the Plattes, the northern Platte is 92% SWE of normal SWE, and southern Platte is 86% of normal SWE. So below normal, not extremely so, but still, a bit still below normal, given again the fact that we've been pretty dry this winter. More specifically for the Missouri Basin, we have the totals here above Fort Peck and then Fort Peck to Garrison, 85% of normal this time of year and 81% of normal this time of year, respectively. You can see how our currents in the dark blue here, shaded area, compared to the 30-year average between 81 and 2010, and we're definitely below that average there. And so that is an important point to make here.
Yeah, these are
the same.
yeah, Trent.
Go ahead.
These are pretty low numbers actually for the mountains, and no, it's probably not record, but it's not. You can look at 2001, which was really a bad year, and we're halfway between average and really bad.
And bad. Yeah. Yeah, thanks, Doug. And yeah, so I mean, definitely the 2001 season is there, and the I'm colorblind, so my apologies if I get this wrong, but it looks green to me. And then the red line showing the average, so definitely in between those two. And then the same thing, the same pattern here for the North and South Platte basins here. We're at 92% of average for the Northern Platte Basin and 86% for the Southern Platte Basin. So again, the snowpack for the Missouri Basin is well below average for this time of the year. Moving to soil moisture, I do want to say, so what these maps are showing are the percentiles of our 0 to 40-inch soil moisture column across the country. The left one is something called NLDAS, North American Land Data Assimilation System. It's a model run by a cooperation of NASA and NOAA. And the right is a combination of model and satellite. But the reason I bring this up is because there's a good number of models that we can use, and we do use, to look at soil moisture conditions. And in general, they paint the same kind of pattern. There may be some variability between them about in different specific locations, but in general, they paint the same pattern, that we're very, very wet or fairly wet in the Ohio Valley. That's what the blue values are showing here, percentiles of, exceeding 80 to 90%, which is pretty significant as far as wetness is concerned. And then on the flip side, really a range from southern Wisconsin, northern Illinois, all the way out to, the dry areas that we know about, parts of Kansas, Nebraska, and then up into the eastern Montana and western Dakotas. We're looking at the 0 to 40-inch soil column that is at or below the 10th percentile or 5th percentile. To give you an idea, 5th percentile, if it's calibrated right, should represent a 1 in 20-year kind of dryness. And the 10th percentile is a 1 in 10-year kind of dryness. So we're kind of sitting in that area there for much of Kansas and Nebraska, and then again, little sporadic areas in parts of Wisconsin, Illinois, and Iowa. And so again, just the soil moisture here in these models and others are really representing that longer-term, multi-month precipitation pattern that we've seen, where it's been wet in the Ohio Valley, a bit mixed in the central Midwest, and fairly dry to the west. Not surprisingly, stream flow follows suit. We tend to see stream flow this time of the year can be buffered by snow, but as I mentioned before, we have below normal snowpack in the mountains, not a whole lot of snow to speak of in the plains and Midwest, and so our stream flow is pretty close to our soil moisture this time of the year. So in the Ohio Valley, we're seeing blues, greens, teals, indicating above average or much above normal stream flow, especially in parts of Ohio and then down to the confluence of the Mississippi. But again, you can pick out the dry areas here, the Wisconsin-Illinois line into eastern Iowa, and then you can see mixed, pretty dry stream flow, or dry stream flow, pretty low stream flows in parts of Nebraska and Kansas, going all the way out to eastern Colorado and Wyoming. So again, all of our hydrological indicators here, the precipitation deficits, the soil moisture, the stream flow, they're all lining up to paint this wet east, dry west pattern. As you would imagine, with it being fairly dry across much of the region, we don't have a lot of current flooding going on right now. These are showing all of the gauges in the entire region between eastern Ohio and eastern Montana, all of the gauges in the region that are currently at least minor flood stage. And basically it's relegated to my backyard along the Wabash, the western Ohio basin, and the lower Mississippi. Those are really the only places that we're currently at minor flood stage. We don't have any gauges in the eastern Ohio, upper Mississippi, or Missouri River basins that are currently at or above minor flood stage. And all of these gauges here on the Wabash and the Ohio that are shown, the Kaskaskia, they're all heading down. So they've reached their peak as far as this current flooding event's concerned, and they're trending downward. Now, when we look at forecasts for flooding this spring, it's a bit of a different story. What this map is showing are gauges. All gauges that are colored are those with a greater than 50% chance of reaching some flood stage this spring. The color of the gauge dictates the level of flooding at which we have that greater than 50% chance of reaching. So the orange is a minor long-range flood risk. The red gauges are moderate long-range flood risk, and the purplish pinkish ones are the major. So a couple different things with these different basins here. We have near normal. There's a lot of gauges that stick out in Kentucky, Ohio, eastern Indiana, but in reality, it is spring, so this is pretty much a near normal type of risk of flooding in the eastern Ohio Valley for this spring. Whereas when we get to the western Ohio Valley, where we do already have some of those gauges in flood stage, that's where we're seeing a bit of above normal flood risk for this spring. You can see one of these gauges down near Cairo has a greater than 50% chance of major long-range flood risk. So there is a little bit of an elevated risk of flooding for the western Ohio Valley. A lot of that has to deal with the fact that this whole region from Ohio down the Ohio Valley to southern Illinois is still pretty wet, as I mentioned, with the soil moisture. And then further north, a lot of snowmelt driven flood risk in the Red River. So we're seeing those gauges there. But you know, on the flip side, we don't see any gauges really west of Kansas City along the Missouri that are at great risk of flooding. And in reality, the Missouri basin overall is at a lower than normal or below normal flood risk for this spring. Okay, so the flip side of flooding, getting into drought. Showing the current drought monitor map. It was released today, but of course it's current March 15th. What this has is 53% of the north central region in at least some form of drought, moderate to exceptional drought. We have all four categories in the region. And you know, some of this has been, as I'll show the change maps here next, over the last few months of how drought has evolved. A lot of this is just persistence from last growing season. We have seen some drought onset or intensification in parts of Nebraska, Kansas, for example, and then a little bit of drought alleviation. But to give you an idea of how long we've really hung on to drought in this region, over half of the region has been in at least D0, which for the U.S. Drought Monitor is abnormally dry conditions since August of 2020. And as some of you know, a lot of these places here that are in drought currently, some of them are about to enter their third consecutive growing season in some form of drought. So there has been a pretty significant amount of drought persistence for some years now, especially in the western part of the region. When we look at drought change, you know how drought has evolved. These are showing the U.S. Drought Monitor change maps. The left is showing since really the start of winter, December 14th. And on the right is the start of the water year, so September 28th of last year. Anywhere you see yellows or oranges here, that's where drought has degraded or worsened since that time period. The kind of gray colors is where we've persisted drought without any change in class, and the green is where we've improved. So you can see, you know, mainly the improvements over the north in parts of North Dakota, Minnesota, eastern Montana. That's where we've again gotten, especially in North Dakota, Minnesota, a good amount of snowpack, and even going back to the start of the water year, a good amount of precipitation in the fall to make up for some of those pretty significant deficits, or at least start eating away at some of those deficits, those multi-year deficits. On the flip side, the oranges, the yellows in Nebraska, Kansas, again, this is something I've been harping on since the start of the talk, that this region is really, especially since the start of the winter, has really seen quite a bit of drought degradation or worsening in the wintertime because of just a very, very dry winter of that time period. And then outside of there, farther west, and as well as in the upper Midwest, we've really mainly persisted drought, just haven't been able to string together enough winter precipitation to get rid of a lot of drought in parts of Iowa, Wisconsin, and Illinois. To give you an idea, again, just kind of the influence of the longer term drought that we've seen on stream flow. What this plot is showing is the highest Missouri River peaks in Omaha each year going back to 1952, and we can see the last year's peak shown here highlighted in this black box. the lowest on record, at least since 1952, since the record's been consistently been kept, and by quite a margin, actually the lowest. And so again, we're seeing the effect of that longer term drought compounded by recent pretty significant deficits or dry weather on stream flow in the Missouri for sure. Picture's worth 1,000 words. To give a picture on it, we have the high water mark in June of 2018, where you can see there was some flooding where the water, this is again in Omaha, the Missouri water came up to the near the steps of that statue. On the right hand side, this photo was taken just a few days ago, and again, and you can see the same statue there on the top left of that photo, and you know, so quite a difference as far as the high and low water marks here. So we've definitely seen a regressing of Missouri flow there in Omaha. Okay, switching gears a bit to the Great Lakes. You know, as I mentioned before, in the upper Midwest, it was very cold, pretty snowy February. So we still have quite a bit of ice, especially in those northern basins on the Great Lakes, in response to those cooler than normal temperatures in January and February. Right now, 43.1% ice cover. That's a composite for the entire, for all the Great Lakes put together. Quite a bit more than this time last year. This time last year, we were at less than 8%. 6% in 2020 this time, and even in compared to 2019, where we had some very cold weather in February of 2019, we were only at 41%. So a good amount of ice. Now, as you would imagine, it varies quite a bit by basin. So a lot. So for example, you know, quite a bit of ice still on Lake Superior. Quite a bit less in Lake Erie, but right now we're well above average ice cover in Superior, near average Michigan, Huron, and below average on Erie. Just one thing I wanted to mention, that this is particularly important for winter, but you know, we still have this effect in the early spring. This more extensive ice cover can help buffer shoreline erosion against winter and spring storms. That is one benefit we get when we see that extensive ice coverage, is that a lot of these shoreline communities or coastal communities can benefit from that, from just a reduction in erosion and other sort of damage that can come from these winter storms. As far as lake levels are concerned, starting with Lake Superior, we are just a little bit below average as far as Lake Superior levels are concerned. But this is something I'll really point out when I show Michigan and Huron. You know, if we go back to 2020, you can see, I mean, we've set records in Lake Superior in 2019. 2020 was well above average, which is the blue dotted line there, and we've really come down closer to average in the last couple of years. The forecasts, which are the kind of hashed red here on the right hand side of this plot, forecasts through the summer are showing, you know, near normal levels for Lake Superior. So nothing extremely low or extremely high, kind of coming back to the average there. That trend downward is really apparent in the Michigan Huron Basin here. The red line is showing our you know, the lake levels from 2020, 2021, 2022 relative to the blue line, which is the average. You know, in 2020, each of the first, I think, 8 months of the year, we set high water level records in the Michigan Huron Basin, and really since then we've been trending downward, partly due to the fact that that basin has been, you know, partly in drought over that time period, especially in 2021. Still above average as far as Michigan Huron levels are concerned. Forecast keeps us there or near there, but again above normal, but much less extreme than what we saw just a few years ago. Erie is very similar, again setting a lot of records in 2019 and 2020 as far as high water levels. Has come down a little bit less so than Michigan and Superior, but you know, the forecasts still show us for summer Lake Erie above normal levels, but again much less extreme than what we saw just a few years ago, which is again good news. Last of the bit of the current conditions here, spring is upon us. The last 3 days here in central Illinois have been in the 60s. Today's in the 70s. It feels wonderful. What that does to us, though, is it pushes phenology slightly ahead of average. So anywhere you're seeing green in this map, that's where our spring phenology model is showing that plants are waking up a little bit ahead of normal. You know, the return period on the how early this phenology is here is, you know, every 1 to 4 years. So not extremely so, just a little bit ahead of average in the southern part of the region. Okay, so moving into some impacts that we've seen at least over the last month. So ag impacts first. Right now when it comes to agriculture, a lot of what I'm hearing from folks is that we're kind of in a wait and see time period. Of course, drought is on the mind of some folks. Folks further east may be thinking about excessively wet soils, but there's not a tremendous amount of impacts to ag right now this time of the year. A couple things I pulled. There is some concern given the last couple of years of drought in parts of North Dakota. Concerns about potentially toxic levels of total dissolved solids, or TDS, for livestock. So that's something to that extension there in North Dakota has been trying to communicate to make sure that you're getting your water levels tested there. And again, that's just a legacy of the last 2 years of drought there. We're hearing about wheat that's starting to break some dormancy along the Kansas-Nebraska border, especially far western Nebraska, and that's pretty close. Maybe just a little bit ahead of average, but pretty close to average as far as when we start to see winter wheat breaking dormancy there. The drier conditions, this is one of the silver linings, one of the few silver linings of dry conditions in the plains. Has helped with calving. We haven't seen the real muddy conditions. We also didn't see, outside of Minnesota and northeast North Dakota, we didn't see a lot of extremely cold air outbreaks like what we saw in really each of the last few winters, and so that does help with calving as well. One thing I want to mention, that last slide that I showed with the early, slightly early dormancy break with the spring, we are seeing in parts of the southern Midwest, including southern Illinois, some fruit tree dormancy break. It's not a super huge concern right now, but we are a good 2 to 6 weeks away from the climatological average last spring freeze for even the southern Midwest. So we will want to watch for any sort of potential freeze on the way because it could increase the risk of freeze injury to those tree fruits. We did see some pretty significant weather over the last month. I think the most noteworthy was severe thunderstorms that moved through the Midwest from Iowa to Ohio on March 5th. All in all, 14 tornadoes, 7 fatalities in Iowa, unfortunately. One of the most noteworthy tornadoes of the bunch was an EF4, which is a very, very strong tornado in south central Iowa. It was actually the farthest north EF4 tornado on record this early in the year. So, a lot of times we'll get our most violent tornadoes when we have a little bit more energy in the atmosphere later in the season. And so it's pretty remarkable to get that strong of a tornado this early. There were reports of golf ball to baseball size hail in southwest Iowa, including 3-inch hail outside of or just southwest Des Moines, and really some pretty severe winds across the whole region. 81-mile-an-hour wind gust was measured outside of Rockford that evening, so quite a bit of damage from that. Also, throughout much of February and into March, there's been some heavy rain events all across the Ohio Valley, but especially ones that have caused minor urban and flash flooding in Ohio. We have the image there of urban flooding in Dayton earlier this month from just some pretty intense rainfall events. And then, one thing that, comes along with a little bit of a snowy February in Minnesota is blizzards. Of course, you get really strong winds, and so travel impacts from very snowy conditions, as well as some strong winds up there that made for some impacts to transportation. Other impacts, fire in western Kansas has been an issue this month and as well as in late February. Of note is one of several fires is the Cottonwood Complex fire near Hutchinson, Kansas. The image here from Sedgwick County has resulted so far 1 fatality. I think part of it may still be burning. But so far destroyed 35 homes, 110 vehicles. Like I said, very unfortunately, 1 fatality. Last time I checked, over 12,000 acres burned, so pretty significant for an early season fire. And then one other impact I want to mention is especially in southern and central Wisconsin, where they didn't get as much snow and it was pretty warm throughout much of December. That warm winter, the lack of really significant snow was a bit challenging for winter recreation in Wisconsin, especially the sports, the recreation where snowmaking is a little bit less relevant, like snowshoeing, for example, snowmobiling, that sort of thing, cross-country skiing. So that was an impact that we saw from just a little bit of a milder winter that part of the country. Okay, moving now into outlooks. Keeping on the fire, I wanted to get this one done. We have the wildland fire outlook for March on the left and April and May on the right. You can see the areas in red. Those are the areas we have above normal significant wildland fire potential. You can see especially for March and April, that's where these drier areas, parts of Nebraska, Kansas, eastern Colorado, those parts of the regions have an above normal wildland fire potential. A little bit decreased, shifts a little bit farther south and west in May, but that is something to note. And as I'll talk about in a little bit, when we look at our 7-day forecast, it's looking wet. That can do a lot to help tamper down some of the potential for fires as we start to green up. But right now, looking at how dry it's been, that's really what's driving this significant fire potential in those regions. I want to start with outlooks with the El Nino Southern Oscillation, or ENSO. Of course, we've been in a La Nina pattern for what seems like forever now. This is our second consecutive winter season. We've gone into La Nina, called the double dip La Nina, or referred to as a double dip La Nina. On the right-hand side, this is the Climate Prediction Center's graphic from March 10th showing the outlook for ENSO and the probability of each phase of ENSO. So blue bars indicate the probability of La Nina persisting or sticking around. The gray bars are for neutral, and then the red are El Nino. And so what we see overall, the April to June forecast, almost an 80% chance of La Nina persistence through that 3-month period. And even as we start to get towards the heart of summer, we're still seeing Climate Prediction Center sticking a 60% chance of La Nina persistence at least into the May through July time period. And even when we get to June, July, August, the climatological summer season was still seeing a greater than 50% chance of La Nina sticking around. So to give you an idea what that means, it's very likely La Nina will stick with us at least into May, if not through the kind of May to June period, and maybe even into summer. Now, early summer La Nina conditions do have precedent. They're not necessarily super rare. There's, as far as what I could tell, 12 to 15 cases, depending on what index you use, since 1950. However, having a double dip La Nina, again, meaning a La Nina event that where we have 2 La Ninas in consecutive winters, having that second La Nina persist into the May through July period is fairly rare. Only really 4 instances of that going back to 1950. So this is of note. And when we get to the monthly and seasonal climate outlooks for temperature and precipitation, that's why I wanted to show this first. We do see a bit of flavor in that persistence of the patterns that have been around for us for a while showing up because of that La Nina persistence.
Hey, and Trent?
Yeah.
Could you also connect this back to the winter that we've seen?
Yeah.
Could you do that a little bit now? Because it was
Sure.
a La Nina winter that we experienced as well. And some of the temperature and precipitation patterns fit that. Not all, but many of them fit the La Nina pattern.
Yeah, when we're looking, when we're in the fall and we're looking, okay, we're going into La Nina. As sort of as a climatologist, we always want to be careful of saying, like, yes, we're going to La Nina, but there's a lot of variability, right? So what we'd like to look for is like a La Nina typology, averaging across as mean wetter, drier here. And some years it doesn't look anything like a La Nina, and then some years like this last winter, it really did in some places. So generally speaking, when we have those La Nina winters, we do see that kind of east-west split as far as precipitation is concerned. And it's definitely one of the biggest signals is wet in the Ohio Valley. And that's definitely something we've seen really going all the way back to the fall. The temperature is something also, I mean, as Doug mentioned, we do tend to see the sort of temperature anomalies, especially kind of the northern part of the region getting cold. And that's really what we saw parts of Minnesota, North Dakota, and northern Wisconsin, especially those kind of it was a bit of a late shifted onset to the cold, which also can come with La Nina winters, but that was something that we did see. So yeah, La Nina, no doubt, as it always is, almost always is strongest in the wintertime, as are its connections with our climate. But and really those features that we saw this winter are at least fairly well associated with La Nina. Okay, so looking at the forecast for the next 7 days, there's a lot of context here with this. So this is showing the culmination of 2 different systems, one that comes through very soon here in the next couple of days, one towards the early to mid part of next week. it could bring much needed moisture to parts of eastern Colorado, Kansas, eastern Nebraska that have been very, very dry. I mean, to give you an idea, we have the forecast here. Amount for eastern Nebraska is anywhere between an inch to maybe an inch and a half. That could be 3 times the amount of precipitation that parts of eastern Nebraska have gotten over the last 3 months. So it is pretty significant. Again, because storms have been very much underperforming there, we do want to again note that this is a forecast, but it is good to see that at least we could see the return of moisture there. That they desperately need that. And then also helping improve some improvement in parts of Iowa, Wisconsin, Illinois, Missouri. Very different flavor of drought, as I'll talk about in a little bit here, there, where we've gotten enough moisture in that area to kind of hang on, not deteriorate drought as much, but not enough to really make some significant improvements. So this could be a good start there. On the flip side, this is absolutely not needed in the Ohio Valley. I see the red in southern Illinois, and it makes my eye twitch. That area is very wet already. They do not need much more rain. But again, like Doug had kind of alluded to, where we're in this pattern where the Ohio Valley does tend to stick around wet. And as I'll get to the outlooks here in a little bit, that's something we're seeing there as well. The other thing I want to mention here, the elephant in the room, so to speak, is the red, the area circled in red here on this map. Very little precipitation, if any, for this very dry parts of South Dakota, eastern Wyoming, eastern Montana. That's really not good to see. We really do need to see, as we start to move towards the climatologically wettest time of the year for that area, it could really use the moisture return. And so we really hoping that the next few systems that go through there can bring some rain to that area. Okay, so looking at the outlooks from the Climate Prediction Center recently released, this is week 2, so this is 8 to 14 day outlook. That takes us basically the last full week in March. Temperature on the left, elevated odds of warmer than normal conditions to the south and west, kind of that blue strip through the central Midwest, a little bit colder than normal central Midwest, although pretty weakly elevated odds. So kind of talk about it leaning that way, not necessarily likely below normal temperatures. Bigger story is the precipitation pattern. The drier colors giving us an elevated odds of drier than normal conditions for the last week of March throughout much of the region. Maybe a bit wetter than normal in the north, although it's a pretty weakly elevated odds. So I think the bigger story here is the darker brownish orangish colors in the central part of the region. So what that's giving us an idea of is that these systems that are coming through the next few days, in the next 7 days, are really our best shot at good moisture return into parts of eastern Colorado, Nebraska, Kansas, before we may likely to move into a little bit of a drier pattern for that last week of March. Into April, this is where we start to see, as I mentioned before, the outlooks that resemble a lot of what we've seen over the last few months, unfortunately, and also tend to have a La Nina flavor to them. On the left is a monthly temperature outlook for April. Again, likely, very likely in some cases, to leaning warmer, and then on the precipitation side, drier in the plains. That's especially the case as we move southwest parts of Texas, but you can see those darker red, darker brown lines over already dry parts of Colorado, Kansas, Nebraska. So this isn't really great news for what is typically a good month for precipitation in that region in April. So that's something that we'll need to watch. And again, the outlook's not really showing a great chances of wetter than normal conditions, or even near normal conditions in April in that region. The wetter than normal area there for the folks who don't want it in the Ohio Valley, it's shifted a bit to the north and east as a trend, as you'll see here in a little bit. But again, the Climate Prediction Center keeping those above normal precipitation chances, leaning that way at least over much of the Ohio Valley and the Great Lakes region. Then the first season here, this is April through June, again leaning warmer and drier for the plains. Warmer really for everybody, and I'll come back to that when I talk about the summary, but likely to leaning warmer than normal for pretty much almost all of CONUS, at least to the central U.S., and drier than normal again for the west. Still hanging on to a bit of wetter than normal conditions here, likely leaning wetter than normal conditions for the Ohio Valley for, again, this is April through June, but again shifting a bit to the north and east as we get closer to the summer period. And then the last season I'll show here is May through July, so getting closer to the heart of summer. You can just see the warmer, the higher odds, the kind of likely above normal temperature odds are shifting. They're expanding to include more of the region, especially the western and southern parts of the region. So likely warmer than normal throughout much of CONUS from May to July is what the Climate Prediction Center is going with here. And then on the right-hand side, this kind of arc of dryness, of below normal precipitation, again hitting some areas that could really use some moisture return in this 3-month period. And so again, the outlooks really aren't showing, aren't real optimistic on wetter than normal conditions. You can also see here as we start to move into the summertime, that area of above normal precipitation that was been present over the Ohio Valley for years now, it seems, has moved off to the north and east. Last bit here about past La Nina events that have persisted into May through July. What I've done here is just taken all of those past La Nina events since 1950, where we've had La Nina in May through July, that 3-month period, and then averaged the temperature anomaly on the left and the precipitation anomaly on the right for all of those years. Now, again, there's a lot of variability between La Nina events. This is just a composite, an average of all these years. So, we want to make sure we take this with caution. This isn't an outlook or a forecast. This is just a look back at what past events have given us. We see overall the redder pretty much across the whole central U.S. It really lines up well with what the CPC outlook is showing us. Again, above normal temperatures during those past late spring to early summer La Nina events. On the right-hand side, not a whole lot of precipitation anomalies there. We do see, unfortunately, in that kind of that central plains region, a bit of a drier pattern in past years. And again, that's lining up with what the CPC is saying for outlooks as far as the April through June and May through July period as well. And as far as the drought outlook is concerned, I mean, this isn't surprising. This is our seasonal drought outlook, goes through the end of June. The darker, pretty much all of the western U.S. Is the highest likelihood of drought persisting. That lines up with the outlooks, what we're seeing. We're already in drought for a lot of this area. The outlooks aren't optimistic about a big moisture return, so it's very likely drought will persist. We even may see some drought development here in eastern Kansas. And then in the upper Midwest, where we see these kind of darker green colors, this is where the outlook is showing drought removal as likely, or maybe some improvement, even though it remains. A lot of that is based on the fact that we have a better chance of seeing moisture return to this area based off of historical years as well as the outlook. So that's important there. But I will say that a lot of this area of eastern Iowa, northern Illinois, southern Wisconsin, some of those deficits are in the 12 to 15 inch range going back to last year. So it's going to take more than just a couple storms to get that area out of drought. So definitely some improvement if we can get some good storms these next 3 months there. But again, that area still has some lingering drought issues. Okay, so summary here. Just wrapping up the current conditions, February really enforced this wet east to dry west pattern that we've seen for a while now. The dry winter really worsened drought conditions, especially in parts of Nebraska and Kansas that just did not get much moisture. Flooding has been a bit of an issue in the Ohio Valley. We see, as far as outlooks are concerned, an increased risk of flooding in the western Ohio Valley, near normal in eastern Ohio, below normal in the Missouri because of the ongoing drought issues. Snowpack below normal in most of the region. Again, 80% Missouri headwaters, 80 to 90% in the Plattes. Great Lakes has more ice cover and near to above average levels that are forecasted at least through the summer. The outlooks, this pair of storm systems are doing a lot of work right now in the forecast. They're set to move through the central U.S. the next 7 days. They will be very important for the plains to pick up some moisture, and so your fingers crossed that those verify. And then beyond that, for week 2, as in the last week of March through most of April through June and May through July, the outlooks are leaning likely warmer than normal for those time periods, and really beyond. I didn't show June, July, August, but it's the same thing, warmer than normal for most of the region. There's what the outlooks are leaning towards, and then the outlooks are also leaning to the persistence of these drier than normal conditions in the west, a little bit wetter than normal conditions, or higher odds of wetter than normal conditions in the east, but then again, it begins to taper off as we get into summertime. Lastly, a drought summary. This is where I wanted to wrap it up. Just because we have a lot of drought in the region right now, and we have different places with droughts with different outlooks. So the first area in South Dakota, eastern Montana, Wyoming, this is an area where we're approaching climatological wettest time of the year. We really do need some serious moisture return to the area to avoid further drought deterioration. Unfortunately, outlooks are leaning drier than normal through July. A bit lower probability on that than in the southern and central plains. But with that said, this area, if you're in this area, again, it's not too early to be thinking about the decisions that have to be made if you do see drought persist, if not worsen into the summertime, because again, the outlooks aren't really lining up with a great return to moisture in that area that is already dealing with drought. Nebraska, Kansas, eastern Colorado, we've seen more drought intensification since the start of the water year in this area. Concerns for moisture for the start of the growing season, of course. There is this possibility of picking up good moisture this week, or over the next 7 days, I should say. Beyond that, the outlooks are mostly leaning, again, or likely drier than normal. So again, the outlooks aren't really optimistic for that April through July period as far as wetter than normal conditions. So again, thinking about what decisions need to be made, thinking about drought, if we don't get good moisture through this next month and we see drought continue through the summertime there. And then the upper Midwest, Iowa, Minnesota, Missouri, Wisconsin, Illinois, we have seen a bit of short-term improvement on top of longer-term deficits there. There's a bit of a better chance both climatologically and in the outlooks for some improvement in April and maybe April through June. The outlooks are leaning drier to near normal as we move into late spring and summer. We'll want to watch for a return of dryness this summer. Last bit of this is that precipitation outlooks are a bit mixed as we go from one place to another across the region. One thing that is consistent is the temperature outlooks from April all the way through May through July are likely to leaning above normal. And as we know, if we're already in drought or we're dealing with drought issues, warmer than normal temperatures as we move into the later part of spring can exacerbate those issues. That's something we'll want to watch. And especially in the eastern part, the Nebraska, Kansas, Iowa, Minnesota, Wisconsin, Illinois, those areas that are already dealing with drought, those are areas where we can see warmer than normal temperatures increase the intensity or the speed at which those drought intensify. So that's really important too. So last, some further information from partners that's available. A lot of the stuff I've pulled for this talk. I'm sure I've gone over time, so Doug, my apologies for that. But I want to thank everybody for sticking with me, and we're happy to take any questions.
Yeah. Hey, thanks, Trent. And I just want to put a bow on this if I can. Maybe go back. We're the usual suspects. You can always find us. But yeah, go back maybe to the last map. That'll be good enough. Last Outlook map. Outlook. Not drought. Yeah, that one. So just to put a bow on everything he's been saying, we already have a lot of drought issues ongoing that have been going on for at least 18 months in a number of areas, right? And you know who you are. I'll just leave it at that. We don't see remarkable improvement in some cases, real worry. Okay, real worry in terms of conditions getting worse or flipping pretty quickly once the real warm season gets here and things start growing and we have a lot more evaporation and evapotranspiration in plants and everything else. So these above normal temperatures are concerning. Obviously, the lack of precip or the below normal precip issues are concerning to those areas in and around the drought areas. So I guess the only other thing I'll say is that there was a lot of agreement this month with a lot of climate models pointing towards this outlook that you're looking at right now in terms of this dryness signal and this warm signal, to be honest with you, across the area. So yeah, what is our confidence level? It's a great question. It's Brian is asking that, and our confidence level is unusually high for this time of year, except I'll say this time of year, looking forward into the late spring, early summer, is usually very low. So it's higher than normal, but it's still not very high. How about that? We have this thing we inside the climate world, we call the spring barrier, and that the barrier is a prediction barrier. in that we have a tough time at this time of year being able to see sort of manifestations of what the models should be saying to us, and they often don't get it right. Go ahead, Dennis.
But Doug, you got to remember, only part of what we're saying in the outlooks is due to models. Part of it is also due to the continuation of La Nina and La Nina patterns. And you also have underlying conditions that are not good to begin with. We need right now to be getting a lot of rainfall in the plains. And even then, that would only catch us up. We still would be behind.
And not to counter you, Dennis, but to say that the models do take into account that La Nina-esque-ness of the atmosphere. So that's already taken into account in the models for the most part. But from a soil moisture and regeneration of moisture, which becomes more and more important as summer goes along, that's going to be the mix in which we hope we don't get this big high pressure dome over us in the middle of the summer that just stops all moisture from coming in. We saw that in 2012, best example I can think of across our area. Not to say this is going to be 2012, by the way. Okay, let me go to some of the questions. There are some good ones in here besides me just spouting off. Anybody else want to say anything, Dennis or Trent, right now in terms of the outlooks? Or I think you blew a pretty good whistle there, Trent, at the end in terms of drought concerns. Do we want to say anything about wet concerns, either agriculturally or any other angle?
Briefly, there are some wet concerns in the Eastern Corn Belt that Trent did a pretty good job touching on. Some of those are potential flooding, though they're not huge concerns. And from an ag perspective, we may have some excessive wetness problems getting some spring planting done.
What is prevent planting while you're on this subject, by the way?
Sure. What is prevent planting? It is part of crop insurance that most producers carry, that if it is too wet to get into a field and get to a crop in the ground and established, you get an insurance settlement, and then you do not have to try to get in to plant something. Because if you try to get into plant when soils are too wet, you can tear up soils, you can compact soils, and then essentially end up wasting seed potentially because soils are just too wet. So it is a part of crop production that came in about after 1993, essentially, to be able to people avoid planting conditions when it's too wet.
Okay. Very quickly, Trent, do you know what the Aussie index is based upon, please? Temperature, snowfall, what else?
Temperature, snowfall, snow depth. So maximum, minimum temperature, snowfall, snow depth. For the vast majority of stations south of the Twin Cities, it's almost entirely temperature driven, which is, except when we have an extreme snowfall season like what we did in Nebraska this year where they just didn't get much at all. But that's what it's based off of.
Yeah, okay, thank you. And Dennis, I know you answered this, but maybe you just want to say a little bit more. Will the dryness and lack of snow cover, I'm talking really the plains here, impact corn and soybeans in the summer due to lack of soil moisture? And really, let's just tack on wheat.
Okay. We have obviously great concerns for winter wheat right now because that area that is in drought and has been in drought extending is much of that winter wheat area from the Central Plains south. Still a lot can happen, but there's been damage done to it because of drought and some other things. Most of the major drought areas are just west of the major corn and soybean growing areas, but it's right on the edge. And the areas that continue to be dry and are projected to be dry and hot are on the western edge of the Corn Belt, in the western part of the Corn Belt. So we do have risk there. Irrigation is big in Nebraska, so there's less concern in Nebraska. They'll probably have enough irrigation to be able to deal with that. So you have a two sides issue again with crop production, potential for being too dry in the far west, and then potential for being too wet, at least to get started in the east. And then in between is kind of an unknown area. You know, Iowa, Illinois, we have some dry areas, but we can work with those if we get rainfall, but we need to get some rainfall later in the spring as we get moving along.
Yep. And moving along, okay, we already talked about confidence being higher than normal for the forecast. We already talked about La Nina's impact or potential impact on the outlooks, and being sort of the dominant teleconnection. If we have it, we're gonna base a lot on it, to be honest with you. Usually we don't have it in the summer. I'll say that too, a strong ENSO component. Okay, yeah, someone's asking, please provide the web address for the past presentation. So could you go down and pull up the, yeah, right there at the very top of the screen, you'll see a couple different places to go to look at. Well, today's will be probably tomorrow, by the way. And
that first one would be incorrect.
oops, we
Yeah,
didn't think that.
I thought I caught all the Purdue, the Illinois links. It's mrcc.purdue.edu now.
Yeah, so use the bottom one of the two for now. Sorry about that. And yeah, and if you need this presentation, I can probably PDF it to you, or Trent can, either one of us, later today if you need it, like in the next few hours. Otherwise, it'll be up there. It'll be up there, if you will, on the website, their website. Okay, are there any comparisons being made to 2012, and is it reasonable to make them? And I would say no, but I would like our other two people to say something about that.
Go ahead, Trent.
Thanks, Dennis. I don't know if there's comparisons or not. I mean, a couple things. Obviously, 2012 we started dry in the spring, and it got worse. And then the death ridge, so to speak, that Doug spoke of, established itself, and nobody got flow out of the Gulf, and which is really our bringer of moisture for the summer, especially the Midwest. One of the big, it's hard to say whether that's going to happen or not this summer. I mean, that's a really, it's virtually impossible to forecast with that much precision and accuracy out this far. But I will say one thing that we do know is that in much of the region in 2012, there were a string of like 5 to 10 to 15 days in March where we hit 80 to 85 degrees. And in some parts of Southern Illinois, we got close to 90. So that kick-started Phenology. I think somebody from Kansas mentioned earlier on our discussions that in 2012, winter wheat was breaking dormancy in late February, which is like 3 to 4 weeks ahead of time. And what that meant is that as dormancy breaks early and we get that heat build up in the spring, we get a lot of evaporation. So we were starting in a pretty big hole in 2012 that even right now, I wouldn't say we have, at least from the temperature side. So that's kind of what I wanted to mention with 2012. But I don't want to underplay the fact that there is pretty significant drought and the outlooks are looking pretty dry for those drought areas.
And all droughts are different, like all wet seasons are different. Is the potential for significant impact out there? I would say yes, there is. And that's why we're trying to hit that very hard. Does it look like 2012? It may not matter if it looks exactly like 2012. The potential exists for some significant impacts. Right.
And I can guarantee it won't look exactly like 2012. That'll be my prediction. What is the expectation as far as controlled burns in the Flint Hills of Oklahoma and Kansas? A great sort of local question. What we've already heard is there have been thousands of fires set a few days ago when the winds were pretty quiescent. Because that's pretty rare in March in Kansas, so in Oklahoma, so you got to take advantage of that. My expectation is that over the next few days, it's going to get too wet for a while for any burns. So we'll have to see how that turns out. But that season has already begun. Yes, I guess that's the best answer I can give you for that. Okay, do we have any statistics or trends in time between rains, particularly for growing season? That's a great question. What is the amount of time between, I guess, storm systems. It's a great question during the growing season. I'm guessing that really matters or depends upon what part of the growing season we're talking about. If we're talking about April and May, that may be one thing. Anybody want to venture out on that limb? It's highly variable, I'll say that.
Well, and it's also very difficult to quantify because what causes storms changes from the spring into the summer. You know, in the springtime, we get your typical large area of low pressure, cold front coming through that causes storm systems. By the time you get into the main part of summer, there are different scales of processes that cause thunderstorms in one area, not another area. So it's a bit different. So trying to quantify variability and trends in precipitation over large areas is very difficult. At a single point, we can kind of do it there. But I don't even have a good answer for that single point kind of thing.
Yep. And there is the thing about needing an inch a week and all that kind of business. At some point in the season, we need X amount of water each week. You know, oh, Trent's going to say something here. Here we go.
Am I? I agree. I completely agree with Dennis there. I did this calculation one time for Peoria, Illinois, Central Illinois, and the average between March and September, because of our warm season, it was about 3.5 to 4 days in between wet days where we get any kind of form of precipitation. And to give you an idea, in 2019, it was almost 2 days. So it kind of cut that in half. So that's kind of where, but again, when you go out to Omaha or Denver, I mean, it's going to be completely different, or it's going to be, different. So
yeah, tends to be longer the further west you go. Yeah. Yep. All right, I'm going to conclude it here because we're out of questions unless anybody has any overriding issues they want to bring up on the panel. Feel free, but I don't think we do. Hey, thanks for those who stuck around to listen to our conjecture there a little bit. Hope this was valuable to you. We'll be back with Dennis, one of our panelists, next month to do the talking. Oh, someone just said, okay. And thank you very much, Dennis and Trent, very much. Trent, you did the lion's share of the work by far. And we'll make Dennis do it next month. So thanks, everybody. Have a great weekend. And happy St. Patrick's Day, and may your team win. Bye-bye.